In this first problem, we're asked to multiply and simplify, and the basic idea is to factor both numerators and both denominators completely, and then cancel like factors. Never cancel part of a factor. This x minus 5 is a factor, it's a binomial. It cancels an x minus 5 or it doesn't cancel anything, so don't cancel the x's specifically. Only the left numerator needs to be factored, and we could just factor it, it's not all that hard, but use clues. One of these x minus 2's is going to cancel this one, so it'd be nice if there was an x minus 2 there, but we don't know that. And this x minus 5 can't cancel x minus 2, so it'd be nice if there was an x minus 5 there, but we don't know that. But since factoring is kind of guessing and checking, I'm going to try an x minus 5. I'm just going to try it and see if it works. If this is an x, then this has to be an x to give me the x squared. If this is a minus 5, then this has to be a plus 2 to give me the minus 10. And 2x minus 5x, 2x minus 5x is minus 3x. So it checked. And so we have these two guys canceling because they're like binomial factors. We have one of these two canceling this one. It doesn't matter which one. I'm going to do this. And now we have x plus 2 over x minus 2. And that is either the answer or possibly this cancels some more. These are not exactly alike, the x plus 2 and the x minus 2, so they don't cancel to 1. But the question is, are they opposites of each other? And one way to find out if they're opposites of each other is to add them. If you add them and you get 0, then they were opposites. But when you add these two, you get a 2x plus a 0. And that's not 0. These x's did not cancel, so these are not opposites. So we're done. Like on the last problem, I would like to use clues to help me guess on the factoring. So one thing I do is I pick what seems easiest to me first. This one seems easiest because everything's positive, and 2 times 3 is 6. And 2 plus 3 is 5. And so I'm pretty sure that this is t plus 2 times t plus 3. Really pretty sure. Now the question is, does that tell me anything else? Well, here's a t plus 2, and 2 goes into 10, so I'm thinking maybe this is going to be a t plus 2 up here. I don't know. If this is t, this has to be t to get me this t squared. If this is 2, this has to be minus 5. 2 times negative 5 is negative 10. And 2t minus 5t is negative 3t. So we've got another one of these solved. This is t minus 5. This is t plus 2, t plus 3. I think maybe there's a t plus 3 in this top one. This would have to be t, this would have to be minus 1, because 3 times negative 1 is negative 3. 3t minus t checks. So now what? Well, I don't know. I don't think the t minus 5 works down here. You can try a t minus 5 down in here, but I don't think so. I think we have to put a t plus 5, I think, and a t minus 1. And I check it and it's 5t, take away t, and that's 4t. Now I have lots of canceling. This t minus 1 matches this factor. This t plus 3 matches this factor. This t plus 2 matches this factor. And I'm left with t minus 5 over t plus 5, which does not cancel to 1 because they're not exactly alike. But if they're opposites, they could cancel to negative 1, and we could write equals negative 1. The question is, are these opposites? And the way to answer that question, one way to answer that question, is to add them and see if you get 0. The negative 5 and the positive 5 are opposites, but the t plus t is 2t, so it does not equal 0. So this is the final answer. It doesn't reduce anymore. Again, I like to start with what feels easiest to me. Since this is a 1t squared and this is a perfect square, I think this is going to be t, 5, 5. But since this is a negative 10, I think we're going to have negative 5s, and you can check that by multiplying. But it works, and I've got 2 of them down. Similarly, this one up here, 4 is a perfect square. I think this is going to be t minus 2 times t minus 2. I'm pretty sure. Now, I'm not sure about these other two, so let's just try this one because it's there. I'm pretty sure that it's going to be a 2t times a t. And since 5 goes into 15, and since I got these t minus 5s down here, I'm hoping that this is a t minus 5. I don't know, it's a guess, but I'm hoping that that's a t minus 5. If that's a minus 5, this has to be a plus 3. It has to be, because 3 times negative 5 gives us a negative 15. 2t times t gives us a 2t squared. But I don't know if I'm right yet. I have no idea whether I'm right. And I get a 3t here, and I get a minus 10t here. And 3t minus 10t is minus 7t, and I wanted a positive 7t. And that really messes things up. But I know a trick. If everything's correct except the middle term has the wrong sign, I can change the signs of my binomials. Instead of plus 3, I'm going to put minus 3. And instead of minus 5, I'm going to put plus 5. And now we still get 2t squared, we still get negative 15, but now we have 10t take away 3t, which is positive 7t, and so we're correct. Now, again, I'm not sure what's happening, but I kind of hope that this 2t minus 3 shows up in here, because 2 goes into 2 and 3 goes into 6, so I'm just guessing. This is just a guess. But if it's correct, this has to be t minus 2. And this is minus 3t minus 4t. That is minus 7t. So check it out. This is correct. So once our guess failed us, once our guess worked, not too bad. So this factor cancels this one exactly. This cancels one of these two. Let's put this one in here. Apparently, this doesn't cancel anything, so it looks as if we have this answer, unless these are opposites and cancel to negative 1. And once again, the way to check if two things, numbers, polynomials, whatever, are opposites is to ask yourself, do they add up to 0? The 5 and the negative 5 are opposites, but the t's add up to 2t, and so this is a good final answer. Here the factoring's a little harder, so I'm going to start with the easiest one I can find, and it seems to be this one, because 7 times 7 is 49. That's a perfect square. I think it's w minus 7 times w minus 7, and sure enough, that's minus 7w's, minus 7w's, minus 14w's. I think I'm good to go. So now, what do we hope on? Well, this is probably the next easiest one. We need two numbers that multiply together to get negative 16 and add together to get negative 6. And that is minus 8 and positive 2. So we have w minus 8 times w plus 2. That wasn't too bad. Now let's go to this one. We've got a 2w and a w. 7 goes into 14, so I'm going to temporarily hope that there's a matching w minus 7. But if that's true, then this would be a 2, a plus 2. And that's not going to work. So my guess did not work. I'm going to have to go with 2w and w, and I'm going to have to try things on my own. So what if this is a minus 7 here, and what if this is a plus 1 here, just to see what happens. excuse me, plus 2 here. We've got negative 7 times positive 2, that's negative 14. Negative 7w plus 4w is negative 3w, that checks. And now what happens here? Notice I've turned this problem from division into multiplication by multiplying by the reciprocal of the second fraction. And so now we have a 3w and a w. And who knows what we need here, but I think it's probably a minus 7. Again, it matches this minus 7. I'm sort of guessing. And a plus 1. This is 1w minus 21w. That's our minus 20w, and things are looking pretty good. So this w minus 7 cancels one of these two. This w plus 2 cancels this one. And it looks as if I'm done canceling. And so we're done.